Hi, good morning, everyone. Today we are going to talk about the new OpenDaylight project. It's called Messaging4Transport. I am an OpenDaylight intern working in this project right now. It's message-oriented middleware bindings for MD-SAL. And I am a PhD student from Instituto Superior Técnico of Universidade de Lisboa and Unesco de Lisboa. Currently, MD-SAL has REST-conf node bindings that you all know. But at the same time, the model basis, it enables easy integration of further node-bound bindings. That means we should be able to have more and more node-bound bindings, leveraging this model-driven architecture. The message-oriented middleware, or it's called MOM, it's very interesting. It's very useful in developing very decoupled distributed applications. There are plenty of open standard application layer protocols for this message-oriented middleware, such as Advanced Message Queuing Protocol, AMQP, then Simple Text-Oriented Message Protocol, STOMP, then also MQTT, OpenWire, XMPP, and many other protocols that you may have heard of. There are many implementations of these protocols, open source implementations, ActiveMQ, Qpid, RabbitMQ, you may have heard and used many of these. So the motivation of this project is to have node-bound bindings with the implementation of these message-oriented middleware protocols in order to expose this data tree, RPCs, and notifications through these messaging protocols. Why? We feel it will give us more interesting use cases to OpenDaylight to have these additional node-bound bindings. As I mentioned, it's a new project awaiting the creation review. The creation review is scheduled to be on the 6th of August during this TSC meeting. So this is like a pre-presentation for this creation review. The goal is to develop bindings for MD-SAL to integrate with message-oriented middleware. At the beginning, we have started designing and implementing for AMQP bindings. But due to the design and architecture, it's pretty easy and straightforward to have further bindings with additional protocols, STOMP, MQTT, or OpenWire, following the same architecture once the AMQP binding is in place. This project does not affect any existing OpenDaylight projects. Now, this gives a very high-level architecture of this Messaging4Transport. Messaging4Transport consists of node-bound bindings. Similar to REST-conf, we now have AMQP-conf, and whatever conf we will have to expose this data tree and notifications to the outside world through a message broker. Currently, we are testing with ActiveMQ. Then, once we publish or subscribe to these events, this can be listened from an outside application that has a listener for these topics that are published from this Messaging4Transport bundle of OpenDaylight. So this is a very simple and straightforward high-level architecture. Now, as you can see, this is very loosely coupled. It's not tightly coupled. Everything is outside. This message broker, it can be external, or it can be a bundle in Karaf. ActiveMQ has a Karaf implementation that can be easily deployed into this OpenDaylight carafe. Now, we have some interesting sample applications. These are supposed to give some motivation, but these are not the definitive use cases. That means these are not the limited use cases. You may think of further use cases. First sample application we came up with is SDN metrics and analytics. Here we are having multiple listeners that are connected to a MapReduce application deployed on top of a Hadoop HDFS cluster. So what are we doing here? We are subscribing to these different topics categorized from this Messaging4Transport bundle that exposes this data tree, RPCs, and notifications from the MD-SAL. And then when we receive this in the listener, we are going to analyze them, potentially through a MapReduce application. We may have some interesting patterns. We may learn something from this. This is analytics and metrics of SDN. We think of this as a first use case. And here you can see we are kind of having multiple listeners, and they are subscribing to the one broker and distributed file system. So it's pretty scalable. Now we think of the second use case, that is software-defined smart buildings. In this scenario, we are having multiple smart devices in the building because this is a smart building. So these smart devices, each of them consist of a controller and a sensor. The sensor usually senses the environment, and it's going to produce some events. The events are listened by the event listener. The message broker is subscribed to these events. So then our Messaging4Transport bundle is subscribed to this broker for these events, and at the same time, the controller decides what kind of action should be taken. Then these decisions are published to this broker through that to the event listener. Then the controller of this smart device, here we have two controllers, not to be confused with the OpenDaylight controller. When I say the controller, it's of the controller of the smart device. The controller will take action based on this. So we have multiple smart devices coordinated by this messaging bundle. This is a second use case we came up with, to have a smart building with multiple smart software-defined applications for software-defined smart building. Then this is a third use case. I was talking to Ed this morning, and I got the motivation for this use case from Ed, my mentor in this project. Yeah. So this is an interesting use case. In this use case, we have multiple deployments of OpenDaylight. As you can see, here we have integrated or federated two instances of OpenDaylight through this Messaging4Transport bundle connected to an event listener for each deployment. So now you can notice we will be able to federate this data tree across multiple multiple MD-SALs of multiple controllers. Now, extending this further, instead of just having two, we extend this further to have a federated controller farm. That means not just two, we are having like more than many deployments, many controllers here, and they publish and subscribe to different topics through this broker. So you can see data transfer between multiple instances, multiple controllers, to have a federated controller farm of multiple instances. So this is the third use case, the extended use case. Now, as the project status, currently I'm working on this as the internship project from May to September 2015. Since this is built from scratch, the code is vendor agnostic. Apache Active MQ 5.9.0 used as the message broker. Because it's very popular and it's open source, with the implementations of AMQP, Stomp, MQTT, OpenWire, JMS, and XMPP with the same architecture. So that means if I successfully implement AMQP, further implementations for the other protocols will be pretty straightforward. The project will be maintained further beyond the time frame with active development. So currently we have the committed resources, me and Tony, and probably you, because we are very new and we welcome your ideas and your time, and we warmly welcome you to be a committed resource here. And we are the initial committers. So in conclusion, message-oriented middleware integration opens up some new interesting use cases as an alternative to the current RESTconf API. So that is my short presentation, and thank you for listening to the presentation. If you have any questions, feel free to ask. And Ed is also here. He will be also happy to answer your questions.
I'm just the guy passing the mic around.
Hello, thank you. It's a very interesting presentation. In my mind, first thing that comes to my mind for the Messaging4Transport, have you looked at making that into a camel component to be able to make it easier for enterprise integration patterns to be built, such as you were showing in your use cases, and deployed against the MD-SAL?
That is a very useful suggestion. I will consider that because I haven't considered that so far, but right now that's a useful suggestion. I will take note of it. And
yeah, because from my mindset,
yes.
As soon as you make it into that kind of a format, it becomes very easy for other developers to start consuming the service.
Yes.
Because from everyone else's point of view, I can read from a file, a JMS stream, a RESTful service, whatever
Yes.
it may be, and it just uses the same protocols every one of the other components would use, and make this very trivial to be able to talk to MD-SAL then via your component if you just make the small modification.
Yes, that is a very interesting and useful suggestion. I will take a note of it.
Okay, cool.
Yeah, thank you. Yeah, sure.
So what kind of events can I actually subscribe to? For example, would I be able to subscribe to Packet-In?
Yes, basically you can be able to subscribe to any event that can be exposed through the current RESTconf, because we are just exposing what is inside the data tree of MD-SAL. So that means you should be able to subscribe to whatever that is available. And also, if you have any suggestions, feel free to let me know, because the project is in a very young age, and your suggestion may actually shape up the project to be a better project. So feel free to give me your suggestions.
So I have a question. You mentioned being able to subscribe to notifications, which is awesome. Are you also going to be able to register data change listeners so you can get changes to the data tree automatically asynchronously provided?
Yes.
Awesome.
Thank you.
Actually, the question is for Ed. Is it?
Not my presentation.
I know, but this morning we were talking about agent and honeycomb, and will this be a kind of the transport layer for the controllers, or?
So in the honeycomb scenario, we talked about this a little bit this morning, the notion of you could use exactly the same ODL components to run a service that's running locally on the server as up in the sky. This would be certainly an option for a transport service for Honeycomb. Depending on what you're going to do, you're going to want to do different stuff. But this is certainly a very attractive option for many use cases.
So one more question. How do we plan to handle different OSGI bundles trying to communicate with each other? Because on one controller, it can augment one kind of model, and then sending the message to the other side, will it have some kind of serialization issue if it has a different version of that model?
So have you given, that's actually a higher level problem probably, but have you given any thought to that, to how to deal with model-to-model translation? It's okay if you haven't.
I haven't thought about it yet, but I don't foresee a problem there. Why do you think it will be a problem? When we receive the events from the other controller, I assume you are talking about this use case. Am I right?
Yes. So in general, when you have two controllers, you assume that they're running the identical modules, the identical versions, and so on and so on. But with Karaf, you can load different kind of versions, and different kind of application can load different kind of versions from that module. For example, I had this issue in OVSDB where I had two versions of topology, for example. So one controller loaded topology version 1710, and the other one, I don't know, 29.8, right?
Yes.
Just listening to the description of what you're describing, having a federated set of controllers talking to each other through a message broker like this, the EIP for this is that you're going to just put some type converters in there. So what you're going to have is that when a message is going to go, say, from box A over to box C, it's going to have to put into its metadata that I am of OpenFlow 1.0 or OpenFlow 1.3. Whatever's going through would have to put that into the message. So when it gets to the broker in the back end, whatever format it is, you would then have a step in there, a processor that would then do the conversion up one step or back one step. It would have to be some kind of degraded configuration. But that's what you would end up having to do. So that type of integration should be possible, but you're going to lose some kind of functionality in a translation from a 1.0 to 1.3 kind of conversion. But I don't see why you wouldn't be able to put something like that in place to make that operate.
Yes, and to add more point, in here, even I'm not assuming that they are from the same version. Let's say that the versions are different. The controllers are not really integrated in literally, because they are still separate entities. They are communicating through the broker, through the event listener. So I don't foresee a problem of having multiple different conflicting versions of bundles.
I think this is a problem where you would have, even with, for example, taking an NFS, you have NFS version 3 and NFS version 4.
Yes.
You interoperate based on what the message version is. So you could put versioning in the messaging itself.
Yes.
And that would be a problem with the orchestration and how do you orchestrate your whole setup. One thing I wanted to point out, one use case is that we would be interested in is we want to look at the packets which the OpenFlow could not deal with. So if we get this, then we won't have to build an application which is part of the controller or the OpenFlow plugin. We can have a standalone application which could look at that packet and make some decisions and program the controller. Right. So that's one other use case.
Yeah, sure. I take note of it, that use case as well. And we have the creation review in a few days. So I will try to address your use cases in the extended presentation for the creation review. Thank you.
Okay, so I think this is related to the two questions that I heard previously, but they're the arrows that are going back into the MD-SAL blocks,
Yes.
from either from your broker or your listeners. There's just the question of state consistency across the controllers, right? I mean, it seems like that could also be a problem potentially with this kind of an approach.
Yes, I understand that your point is I'm writing back to the data tree.
The arrows imply that.
Yes.
One question, the data broker clustering is using akka transport. Why aren't we implementing the same thing in akka transport and just using a different kind of message bus when we already have akka transport implemented inside the controller?
Are you suggesting to use the existing broker clustering?
No, I'm saying that akka
Yes.
has its own message broker and messaging mechanism that is already been used in the data broker clustering.
Yes.
We can leverage the same akka framework to have the message broker, right?
This is an external message broker to communicate to the external applications with the protocols we discussed, AMQP, XMPP, MQTT, OpenWire, and STOMP. I'm not sure whether they exist, because I'm not really familiar with the technology of akka cluster, so I'm not really sure whether it provides the features we need. If you are sure, you can let me know. I will have a look as well. Because this offers us an opportunity to subscribe to these specific events outside the controller through this broker with a unified architecture. I'm not really confident whether it's actually provided.
I didn't get what you're trying to say. A message broker is something that usually implements the same thing.
Yes.
You register for something, for subject or
Yes.
something, and you get messages in
Yes.
some protocol in some format.
Yes.
I believe that ActiveMQ has some protocol.
Yes.
akka has also some protocol. The advantages in akka that you can change your persistency layer. You can use protocol buffers, or if your application needs to pass a lot of data from point A to point B,
Right.
In messages, you can implement a protocol buffer. If you get arbitrary every hour 2 to 3 messages, you
Yes.
can use REST. That's the flexibility that akka gives you. The question I'm asking is, why didn't you look if there is some kind of message broker inside the controller and trying to reuse it to implement the high-level functionality that you try to do here?
I think this is primarily about bindings, right? And so the broker has a message broker inside of it that handles stuff internal. But the question is, how do you communicate with other systems that are outside the controller? Things like the enterprise service bus, lots of stuff can plug into.
Yeah, yes, that is a good question. I didn't really go through the akka, so because of my limited awareness of akka, I cannot answer the question right now. But I will go through it and probably answer I have already sent you the presentation through the email list. I will go through akka and let you know whether it's a possible alternative, or if it has some problem, I will also let you know. Because when I started the implementation, I just found one of the possible alternatives and started on that. So if it can be done, I will modify it. Any other questions or suggestions for improvements? Yeah, so probably see you all again during the creation review. And thank you for listening.